So we have an audio signal of 1 kilohertz is used to modulate a carrier wave of 500 kilohertz. So that's the carrier frequency FC as presented here in the frequency spectrum. The FC they are speaking is this 500 kilohertz. Determine the sideband frequency. Determine the sideband frequency and the bandwidth required. Determine the sideband frequency and bandwidth required. Remember, speaking of sidebands, we have lower sideband and upper sideband, lower limit and upper limit respectively. Upper limit, you add the signal strength to the carrier wave. Lower limit, you add this the frequency of the signal. You subtract the frequency of the signal to the carrier wave. So we solve it as follows. We have the carrier frequency FC as 500 kilohertz, and we have the signal frequency Fs as 1 kilohertz. As discussed earlier, the AM wave has sideband frequency. This is the upper sideband and this is the lower sideband. Therefore, we have you see how simple it is. We have 500 kilohertz, we have 1 kilohertz. So it's just plus 500 plus 1, you get the upper sideband. 500 minus 1, you get the lower sideband. So you have the upper sideband as 501 kilohertz and the lower sideband as 499 kilohertz. So the bandwidth required is actually the difference between 501 paka 499. So you take 501 because our interest is the distance now from the upper sideband to the lower sideband. This distance here is the bandwidth. So if we take 501 minus 499, you will come to realize that is 2 kilohertz. So the distance from the upper sideband to the lower sideband, or lower sideband to the upper sideband, is what we call the bandwidth. As you can see, as we said earlier, that in amplitude modulated, simply the bandwidth is usually twice the signal strength. So as you can see here, the signal strength was 2 kilohertz. So twice this is what was the bandwidth. So 2 times 1, you get 2 kilohertz. Another question. A carrier wave of 500 watts is subjected to 100% amplitude modulation. Okay, you have carrier wave of 500 watts is subjected to 100% of amplitude modulation. So determine the power in the sidebands and second the power in the modulated wave. We know when they say is 100% amplitude modulated, you remember I said modulation factor is actually, it shows by how much the original signal has been modulated, the percentage, whatever. So as they say here 100% amplitude modulation, it means the modulation factor, that by how much the signal was modulated, is now 100%. So our modulation factor will be 1. Okay, because 100% means 1%, you have to convert it into fraction now, because that's a factor, it's usually expressed into fraction. So it is 1. So automatically the power in the sidebands, you remember as I said earlier, that power in the sidebands is equal to half modulation factor squared times power in the carrier wave. Okay, I said here that power in the sidebands is equal to half modulation factor squared times power of the carrier wave. So automatically utakuwa na half modulation factor ambao ni 100%, 1 squared times power in the carrier wave, which is 500, you get 250 watts. The power in the modulated wave, you remember this formula I said earlier here, that total power is equal to the power in the carrier wave plus power in the side bands. So to get power in the modulated wave, okay, it means is equal to the power in the carrier wave plus power in the side bands. You get the total power, which is the power of the modulated wave, the final modulated wave. So since we have power of the carrier wave as 500 and power in the side bands as 250, the total, which is 750 watts, is the power of the modulated wave. As you can see, questions are easy, and as you can see. Another example is that we have 50 kilowatts carrier is to be modulated to a level A of 80%, B to 10%. What is the total sideband power in each case? Okay, so it's just like the previous case. We know from this formula here, half MA square PC, where first case modulation factor is 80% squared, so you get it 0.8. 80% is 0.8, and you get that power, and 10%, so it's that way you get 0.25 kilowatts. Another example is that we have carrier peak voltages. We have carrier peak voltages of 0.05 volts and frequency of 200 kilohertz, which is amplitude modulated by a signal of peak voltage 10 volts and frequency 1 kilohertz. So here we are having carrier peak voltages of 0.05 volts, okay, and we have which have frequency of 200 kilohertz. Amplitude modulation by signal of peak voltage 10 volts, now frequency 1 kilovolts. First, find the frequencies of the output spectrum. So wakisema find the frequencies in the output spectrum, it means utafute in form of upper sideband, lower sideband, and the frequency ya carrier. You can solve it together kwamba tumeambiwa carrier of peak voltage hiyo hapo na frequency yake ni hiyo. So first we know the frequency of the carrier is 200 kilohertz. So we know upper sideband is just the summation of frequency ya carrier plus frequency ya signal. So we know the signal has frequency of 1 kilohertz. So plus 1 kilohertz here you get 201 kilohertz. Minus 1 to get the lower sideband is equal to 199 kilohertz. So these are the three frequencies that we will have, and so they are listed: 199, 200, 201. The peak values of output components if modulation factor is 0.5 and voltage gain A is 100. As I said here, that the peak values for the sidebands is given by MAEC divided by 2 for each, kama nilivyoelezea hapo. So it's what we are going to do here. So kwa mfano tutatumia hii njia leo solvia hapa, that this time we have our M as MA 0.5 and we have our EC as 0.05. So directly tukianza na EC ni 0.05. So here MA is 0.5 times EC is 0.05 divided by 2. We get 0.0125. As I said earlier, what is in the upper sideband is what will be in the lower sideband. So here also, because it's the same formula, it's 0.0125. But remember, this we have just found the input. That's why we are given the voltage gain here, so that finally we find the output. So we know the gain is equal to voltage output over voltage input. So finally our V output will be the product of gain and the V input. So for each we do the same, the gain times V input. The gain is 100. So if we take 100 times that, which is the V input, so you multiply by 100 here, so you will come to get this value here. Similarly to this, multiply by 100 is why we have the two values there. In 0.05 times 100 we get 5 volts, as you can see here. So simply that's how we do it. So coming to this example also, you see we have a carrier of 100 volts and frequency 1500 kilohertz. modulated by 60 volts, 1200 hertz. So sinusoidal signal, calculate the modulation factor and express this as a percentage. We know from our formula here that modulation factor is equal to the E of signal of the E of the carrier. So we know that E of the signal is 60 volts. We have 60, whereby the E of the carrier is 100 volts. So this is a modulation factor, which is 0.6, as you can see. So percentage multiplied by 100, you get 60 hertz. Another final example is that we have a carrier with amplitude of 140 volts is modulated by a signal with amplitude of 80 volts. What is the percentage modulation? What is the amplitude of the lower sideband frequency? Again, it's the same thing that as we have done earlier here, that the the percentage modulation is equal to E of the signal, in which here we have a signal of amplitude 80, and we have E of the carrier, which is 140, and that's when we get 57% if multiplied by 100. Again, we have the amplitude of the lower sideband. As I said here, if you want to get the amplitude of the lower sideband voltage, you use this formula. So we take our modulation factor 57%, which is 0.57, because percent, then you have to express it in fraction, times E ya peak ya carrier ambayo ni 140 divided by 2. So we get our answer as there, that is, the answer is 40. So finally, we have another example, an AM wave, the one that uses the general wave AM wave equation, as I said earlier. So we have an AM wave is represented by this expression. What are the minimum and maximum amplitudes of the AM wave? That's the first question. What the frequency components are contained in the modulated wave, and the amplitude of each component, the voltage amplitude. So the solution is as follows. We know we are given this, okay, equation 1. So we know with the standard AM wave equation, the standard, as I said here, that you have to know this standard. You have to know the standard AM wave equation. So it is what they have, shown here. So finally, just compare, okay, just compare. That EC is the carrier amplitude. When you compare, is 5 volts. Let me remove that. So EC, you compare, is 5 volts. M, the modulation factor, you compare, is 0.6 volts. Okay, yeah. So if you are asked to find the signal frequency, because we want to compare that this is the angle, you just compare with the angular frequency. As you can see here, angular frequency of the signal, you compare it with that. We know that angular frequency divided by 2 pi is equal to the frequency itself, because 2 pi times frequency is equal to angular velocity. So we know angular frequency divided by 2 pi, you get 1 kilohertz. You compare with the carrier, okay. So you know, divide by 2 pi, you get the frequency of the carrier that way. So finally, we looked for this kwa sababu zinatusaidia kwenye kutafuta our 1 and 2, because kutafuta frequency components means we have to find the sidebands, the upper sideband and the lower sideband. So kujua upper sideband na lower sideband, lazima tuwe na carrier frequency, lazima tuwe na signal frequency. Kwa tunazipata kwa kukompare kama tulivyofanya hivyo. Vile vile kujua minimum na maximum, lazima tuwe na modulation factor na E ya carrier wave. So ndio maana tumeitumia hivyo, kwa tuna compare na kupata hizo values. So we know the minimum amplitude, okay. Minimum amplitude ni kama vile vile tu sidebands na upper sideband na lower sideband, okay. Kwa unapoulizwa maximum amplitude, minimum amplitude ni kama lower sideband na upper sideband, only that kule inakuwa ni frequency, huku inakuwa ni voltages. So utaona range yake ni vile vile kwamba E kwa itakuwa ni ya carrier, upper sideband na lower sideband. Ukiulizwa minimum na maximum amplitude. So maximum amplitude itakuwa ni kama upper sideband, E ya carrier plus E ya signal. Ukitakuwa E ya carrier minus E ya signal. You remember though E ya signal ni sawa sana modulation factor times E ya carrier from this expression here. From this expression here. Okay? From this expression here. So finally our E ya signal is sana modulation factor times E ya carrier. So it's what they have done here. Modulation factor times E ya carrier. E ni E ya signal, E ya signal. So you minus and you add, you get the range, the minimum and the maximum. So you take E ya carrier minus E ya signal. This is the E ya signal. You get the lower limit, the minimum amplitude. E ya carrier plus the E ya signal, you get the maximum amplitude as given. So the second question that requires us to find the frequency components means you have to find the frequency ya carrier, upper sideband na lower sideband. It's just the same that we know the frequency ya carrier, lower sideband, upper sideband. As we have already calculated, it's just the issue ya kumalizia. 336 ndo ya carrier, so plus F ya signal, you get upper sideband ambao ni 1 minus F ya signal, you get the lower sideband as they've done there. So our last part, which is the amplitude of each component, you remember this formula as I said earlier, that the peaks is equal to the product of modulation factor E ya carrier divided by 2 because they share the upper sideband and the lower sidebands. Okay, so it's just simply a matter of plugging in the numbers. You have E ya carrier, which is as you have calculated here 5 volts. And we have E modulation factor, which is 0.6. So 0.6 times 5 divided by 2, as you can see what they have done there. So one thing important here to note, as I said, this expression is very important. Keep it in your mind that what does M stand for, where does EC usually located, where WS is usually located, and where does the sign. Kwa ni wewe utafuta namna ya kuiweka hapo. So we have another example here that we have a sinusoidal carrier voltage of frequency 1 megahertz, amplitude 100 volts. Is amplitude modulated by sinusoidal voltage of frequency 5 kilohertz, producing 50% modulation. So we have things to note: the signal frequency, the modulation factor, the carrier frequency. Okay, the carrier frequency. So calculate the frequency and amplitude of the lower and upper sidebands. So again, we know this is the lower sideband, this is the upper sideband. If you have the values, this is not a problem. Okay, if you have the values, it's not a problem. So just put in the numbers: 1000 minus 5, 1000 plus 5, you get your answer. Just remember what is the signal frequency, what is the carrier frequency. Again, calculate the amplitude. It means the voltage amplitude of the lower and upper sidebands, as I said, is given by the product of modulation factor EC divided by 2. As you can see, amplitude of the carrier, the amplitude of the carrier is 100 volts. Okay, the amplitude of the carrier is 100 volts. So just put in the number modulation factor, which is 5%, 50%, 0.5 times 100 divided by 2, you get your answer. Another question is that a carrier wave of frequency 10 megahertz, a peak value of 10 volts, is amplitude modulated by 5 kilohertz, sine wave of amplitude 6 volts. Determine the modulation factor, the sideband frequencies, and the amplitude of the sideband components. Draw the frequency spectrum. Okay, the modulation factor, we know modulation factor is equal to the E of signal over the E of the carrier, as they have shown here. So we know the E of the signal, as you are given, the signal is 6, and the E of the carrier is 10. So you put it in the numbers and get your modulation factor. Sideband frequencies, we know the upper sideband and the lower sideband respectively. You're just required to know what is the frequency of the carrier, frequency of the signal. As you can see, the carrier is 10 megaohms, and that of the signal is 5 kilohertz. So just take make sure you are careful with the units, otherwise you'll mess up things. Make sure you are careful with the units. Ndio maana unavyoona hapa ni tofauti. Hapa ameiconvert kwenye mega, ndio maana imekuwa hivi, as much units ibaki kwenye mega. But otherwise you can just put 10 mega in your calculator. 10 mega is 10 power 6 minus 5 kilo, which is 5 times 10 power 3. So you get the lower sideband. If you add, you get the upper sideband respectively. Just be careful with the units. Again, amplitude of each sideband, as we have been doing that. Again, you just use that formula. I think now you can do it. The issue here, the most important factor to note here, is this what they call the frequency spectrum. The frequency spectrum. Frequency spectrum ni diagram hapa. Sawa? It should be a diagram. Ukiwekewa voltages utaziweka, lakini usipowekewa voltages, just simply the issue of drawing hapa na kuandika hii ni ya carrier wave 10 megahertz, kuweka upper sideband na lower sideband utaweka frequency yake, kama hapo tumecalculate ni 10.005 megahertz na huku ni 9.995 megahertz. Kwa utaandika namna hiyo, but kama kuna voltages kama hivi, lazima uiplot kwenye graph ya voltage against time, okay, against frequency, voltage against frequency, kwamba apart from writing hicho ambacho nimesema hapa, lakini lazima uindicate kwamba hii carrier wave voltage yake ilikuwa ni 10 volts. Okay, hizi sidebands kama tulivyo calculate hapa ilikuwa kwenye 3 volts each. Okay, 3 volts each. Another question: consider an optical communication system operating at wavelength ya 8 nanometers. Suppose only 1% of the optical source frequency is available channel bandwidth. Kama nilivyokuambia, bandwidth ile inatusaidia sisi ni range, kwa sababu ni range ambayo ile carrier frequency inaweza ikafanya kazi. Inatusaidia kupata zile ranges ili station tofauti tuziassign zile range zote ziwe within the same signal operating point. Kwa unakuta signal ni ile, lakini tumefanya modulation ili zisimix up kutoka station tofauti. Ndio maana hii station tunaipa 25.5 FM, hii tunaipa 66.6 AM au nini whatever. Tunaipa frequency kila station kivyake kulingana na bandwidth ambayo ipo. Sawa? So inategemea bandwidth inaweza ika-accommodate channel ngapi. Kwa unategemea hapa. Sawa? So suppose now that only 1% of optical source frequency is available channel bandwidth. It means kutoka kwenye source, frequency ya source. Sawa? Hapa tumepewa wavelength. Kumbuka optical communication ni electromagnetic wave, and we know that velocity is equal to wavelength times frequency. So from here frequency we know ni velocity over wavelength. Velocity ya electromagnetic wave tunajua ni 3 times 10 power 8, and we know the wavelength tumepewa, so tunaweza tukapata frequency. So 1% of this ndo is available as the bandwidth. 1%. Okay, 1% is the available bandwidth. So how many channels can be accommodated for transmitting? 1. Audio signals requiring a bandwidth of 8 kilohertz. Second, video TV signals requiring approximate bandwidth of 4 megahertz. So the first thing, as I said, is to calculate this 1% ni kiasi gani. So we know, as I said earlier, that frequency is sana velocity, which is electromagnetic wave 3 times 10 power 8 over wavelength 8 times 10 power negative 7, and we get this is the total bandwidth that can be offered by this communication, but only 1% is available. It means 1% of this. So 1% of this is this value here. Don't usije ukajichanganya kwa kile je change. Angalia hizi values zime change, okay? Yeah. So only 1% is available. Only 1% is available. So finally, the number of channels for audio signal, kama zenyewe zitakuwa zinahitaji bandwidth ya hii hapa, tutaangalia channel ngapi ambazo zitakuwa zina hizi bandwidth zinaweza zikawa accommodated kwenye hii. Kwa tutachukua hii hapa divide by the bandwidth reason ambayo hizo channels zinahitaji, hizo audio channels. Kwa tutaangalia tutapata this number of channels. Okay? Also for TV signals the same. Kama hizo TV signals, hizo station zinahitaji bandwidth ya 4.5. So kama yenyewe inaweza kuoffer only this, tunaweza tukadivide hapa tukajua ni channel ngapi ambazo zinaweza zikawa afforded. Kwa ni application ambao wanafanya katika mitambo ya kujua kwamba bandwidth fulani katika mkoa huu tunaweza tukaaccommodate channel ngapi za TV, channel ngapi za radio. So special case, sometimes tumezoea kwamba tunapewa carrier frequency na signal frequency, one value na hii one value, but sometimes they give you this as a range. Okay, they give you this as a range. Kwa mfano hili swali, AM signal with carrier frequency of 15 MHz is modulated with frequencies of 2 kHz na 3.5 kHz. What are the sidebands and bandwidth? Okay, so we know kwenye frequency spectrum yetu frequency ya carrier ni 15 MHz. We have upper sideband na lower sideband. Okay, lakini tuna mbili, so it means tutakuwa na frequency spectrum mbili. The first frequency spectrum is for lower limit of the signal frequency ambayo ni 2 kHz. Kwa for the first tutakuwa na 15 mega plus 2 kHz, 15 mega minus 2 kHz. Then the second spectrum tutakuwa na ya upper signal limit ya signal frequency, so tutatumia hii hapa. Kwa tutakuwa na 15 MHz kama kawaida, only that tutakuwa na 15 mega plus 3.5 kHz na huko 15 mega minus 3.5 kHz. Yeah, so we have this and this. So finally we have to calculate our bandwidth. So you can see that now our final spectrum will be in form of having 4 parts. Okay, having 4 parts. This is the lowest part. So as you can see, this is the smallest compared to this and this. This is the small, sababu yametolewa sana. Kwa hapa ndo ataanza huyu hapa 15 minus 3.5, 15 minus 3.5, huyu atakaa hapo. Then hapa atakaa huyu 15 minus 2. Okay, hapa atakaa 15 kama kawaida. Hapa atakaa inayofuatia ambaye probably ni huyu hapa ambao ni 15 plus huyo 2, na huko ni 15 plus huyo 3.5. So finally our bandwidth ni kutoka huku mpaka huku. Kwa hiyo it means tutachukua mkubwa kabisa minus mdogo kabisa. So finally tutakuwa na our bandwidth taking the largest value minus the smallest value, the largest value minus the smallest value. Okay, the largest value minus the smallest value. So in other words ni kwamba tutatumia, tukiulizwa bandwidth hapa tutaassume tuna hii moja tu, sawa. Kwenye sidebands tutaandika kwamba sideband range ya sidebands. Kwa katika kuandika kwetu sidebands tutasema lower sidebands ni kutoka hii value hapa mpaka hii value hapa. Kwa tutazicombine lower sidebands pamoja. Again tukisema kwenye upper sidebands tutazicombine pamoja. Upper sidebands tutazicombine pamoja, kwamba itakuwa ni kutoka hii the smallest value ya lower sideband ya upper sideband mpaka the largest value ya upper sideband. Kwa such questions, kwa vile tumepewa in range, majibu yake tunaweka kwenye form ya range. Kwa sidebands zitakuwa zile sidebands tulizozipata tutaziwekea range yake kwamba kutoka hapa mpaka hapa, na zile upper sidebands tulizopata tutaziwekea range yake kwamba kutoka hapa mpaka hapa. Then finally the bandwidth ndo kama nilivyosema, unachukua mkubwa tu mdogo. So ni as if kwenye bandwidth unamuignore huyo hapa, ni sawa sawa tu na huyo hapa. Kwa unafanya kama kawaida as if na pekee, kwa sababu zikesi tumetumia tu za 3.5 ya yule mkubwa. Sawa, unamuignore yule mdogo, unatumia yule mkubwa tu kutafutia bandwidth. sawa. So we have further examples here. Kwa mfano, we have maximum peak to peak voltage of AM wave is 16 volts and the minimum peak to peak voltage is, kwa na maanisha kitu kama hiki hapa, kama nilivyosema AM wave inavyokuwa, kama unakumbuka. So peak to peak voltage inakuwa hapo, peak minimum peak to peak voltage inakuwa hiyo hapo, hizi graphs kama nilivyoelezea mwanzo. So as I said earlier kwamba tunapoongelea V maximum tunaongelea half ya peak to peak, easy maximum peak to peak. So tunapoongelea maximum inakuwa half ya maximum peak to peak maximum voltage. Kwa maximum peak to peak ni 16, so half yake divide by 2 tunapata V maximum. Kama unakumbuka mwanzo, you can refer hapa wakati naelezea hizi, okay? You just go back and refer. So again, V minimum is equal to peak to peak ya troughs hizi hapa, so inakuwa ni 4 divided by 2 napata hiyo. So modulation factor unakumbuka formula yetu, V maximum minus V minimum, V maximum plus V minimum, then you get your value hapo, 8 minus 2, 8 plus 2. Okay. So again we have a question here, a carrier of 100 volts 1200 kilohertz modulated by 50 volt. I assume sasa hivi umeshafahamu, so you can solve that. Na hili limejirudia tena, so you can solve that.